Recording. Okay, the redox part. So just to review number 15, right? Hydrogen always has +1, oxygen's always -2. When I do the math, that means there's two hydrogens. There's one plus with a +1 charge. We add that to carbon. Then we have three oxygens. Each one has a -2 charge. We set that equal to 0. All right, just to review. Then by doing the math, we find that carbon has to equal a +4. So that's how we find oxidation numbers. Some have rules, some we got to figure out with a little bit of math. Okay. Now for the half reactions in the redox part. Okay, there were some common mistakes. Number one, I should have seen oxidation numbers above each one of these. That was worth 1 point. Okay. This was actually worth a total of 9. So if you left it blank, that's 9. Okay, I need you, if you're out there, I need you to put your pencils down because I haven't graded some of yours. Everybody got that? So make sure you don't have a utensil in your hand right now. All right. So then I connect. Well, I see that, let's see here. Sodium is a non-player because its oxidation state has not changed. It went from +1 and it stayed to +1. So sodium's not a part of this, right? Then I look at chlorine. Chlorine goes from 0 to -1. Well, how did it do that? That means it gained an electron, right? So which one's gaining? Reduction is gaining. Reduction is gaining. That means chlorine is what's being reduced. When I write this, chlorine starts off as 0, and it gains an electron, to form chlorine -1. So you got a point for having chlorine. You got a point for all your oxidation numbers across the top, for the right number of electrons, and for the right placement of that arrow. Okay, so that 4 points came from that. Then if I look at bromine, bromine goes from -1 to 0. That means it's lost an electron. So bromine's being oxidized. Bromine starts off as -1, and it produces, because we can't put a minus sign by losing, an electron plus bromine 0. 9 points there. Okay. Then if I go to, so that's going to clear out. If I go to the back side here, right, I start with lithium. I don't need to balance any of these. Guess what the direction said? Lithium plus water. That's a point for having all that. This is single replacement, and lithium will bump out hydrogen because metal wants to bump out a metal. So now hydrogen gas, H2, because it's diatomic. And what's left over is Li2O, because oxygen has a -2 charge. It crosses that down to lithium, Li2O. All right, and this will happen because lithium will bump out hydrogen. The next one, magnesium plus lithium chloride. That's a point for having both of those correct. Then I look, will magnesium bump out lithium? It will not, so I should have had an R. On your test, if you put products here, it will be counted wrong. Some of you did, 1 or 2 of you did, and I crossed it off, but it will be counted off on your test, okay? Number 19, a solution of sodium 2 carbonate is added to ammonium chloride. All of that, right, is 1 point. We'll give you, and because this is double replacement, you do need to give me products. So now I have sodium chloride plus ammonium 2 carbonate, right? Some of you left that, and I counted it wrong because you need AQ, you need AQ. There's both aqueous. Some of you did that, and I counted it wrong because what you didn't write was an R. This is a no reaction because both of those form an aqueous solution. Okay? The next one, number 20 and 21. All right? So number 20, methane gas, CH4, is burned. That implies O2. Because this is combustion. It's burned, that means it's combustion. Always forms carbon dioxide and water. Now, I did have a few people put no reaction right here, but this is a liquid. This is a gas, actually. You don't need to have those, but now you know why it's not, like, why it does happen. Okay, and that's all I didn't need to balance, okay? Then at the bottom, a lot of people missed aluminum, AlBr3. Aluminum crosses down a bromine. Once again, we should not have a utensil in our hands right now. Okay? Is added to phosphoric acid. Well, this is the same as your percent composition. H3PO4. Phosphoric comes from phosphate. One second. That forms aluminum, phosphate. Those threes cancel out. And this is going to form a solid if you look at your solubility chart. And then HBr, all acids are aqueous. So it should have been AQ. And if it says to balance if it occurs, we would balance this one because this reaction does happen. In this case, you just left it alone. Okay?